Okay, this is a short intro to Code.World, showing you how to use Haskell on Code.World. The first thing you need to do is type code.world/Haskell. If you don't put the /Haskell, you won't have actual Haskell. That will be a problem for you. If you are like me, you can sign in with your Google account, but if you're a CPS student, you can't. Okay. So first thing we're going to do is we're going to get the starter code. If hopefully you have access to the website, you can copy and paste the starter code. Let's try to type it from scratch here. So overloaded string. Go. Looks like I typed it wrong. Main equals do put Sterling successful started. Okay. On see if I can get this to work. Why does it not work? Overloaded string. Well, I guess I better go and look it up. So what neon cs.info apcs Haskell Code.World. Go. Here's the Code.World intro. Here we go. I forgot my language overloaded string. And then we're going to need to do some other imports. So we're going to copy and paste the code from here. Paste it in. Notice that there's extra spaces. You don't want those extra spaces there. And I'm not going to do the drawing of the coordinate plane yet. Drawing of pictures, coordinate plane. And then we'll also put a circle. Now go to the right and hit run. Okay, here's code compiling. And after you compile it, on the right-hand side, there's a little window. And on the bottom of the window, you see something that only shows up if you print things. That's the area where your output text shows up. It's actually useful because if you're debugging, sometimes you can't figure out why something doesn't show up on the screen. You could print out, say print its and find out there are no items in something like that. Okay. One of the biggest problems I see people having is mixing in colors with other stuff. So I think I'm going to make a something around a 4x4 checkerboard. So that's going to involve putting alternating colored squares on different points. First of all, let's try to get one. I'll call my variable pictures. And I see I'm going to make a pics variable, which has a list of, well, let's try solid rectangle. I think I want 1x1 solid rectangles. And then I'm going to move them. Translated. Looks to me like the center of the unit square, 0 to 1, is 0.5, 0.5. So let's see. X plus 0.5, Y plus 0.5, solid rectangle. Now I'm going to X's go from, let's say, 0 up to 4, and Y goes 4. Pretty soon we should be able to take a picture of this. I'll look at a picture of it. That should, well, let's make it 0 to 3 for the Y's just so X and Y are different. I think we would be okay, but these rectangles are all the same color. So that's going to be kind of ugly. Unfortunate. Let's see what happens. Of course, you know what's going to happen. It's going to be a great big rectangle. A 4x3 black rectangle. Yep. Okay, that's what you thought. So in order to color these, I'm actually going to take a slightly different approach. I'm going to generate a list of the centers. That's basically the same code, but now I'm not doing it all at once. There's my list of centers. And now I could also make a list of colors, which let's see, red, black, alternating. And now I want to combine those. So that means I'm going to need a draw square function, which takes in a single center and the color. And I'm going to, well, there's two things, colored, color, translated XY. And now I need to let probably a solid rectangle 1, 1. Okay. So that draws a single square. And now I want to put them all together. So new pix, map, draws, oh, almost. This draw square function takes in 2 inputs and not one ordered pair. I guess I better have centers and colors is zip of centers and colors. And I haven't been writing type signatures. They're all in my head. I'll write some down to help you and everyone else follow. So centers is list of ordered pairs, double, double. And colors is a list of color. The draw square function takes in an ordered pair, double, double. And it also takes color and puts out a picture. Okay, and so centers and colors is actually an ordered pair of and the first item in the ordered pair is an ordered pair. Sorry, I said that was an ordered pair, but it's not. Ordered the list with a nested ordered pair item. Okay, I really just got to that point because I wanted to slow down a little bit and make sure you could see all the pieces before they got put together. So the new pictures is basically going to be map, draw a square on the centers and colors. But this doesn't actually work because draw square takes in 2 inputs, but colors and centers, it gets a list of, like it gets ordered pairs. So let's see if we can make ourselves a little lambda here that takes in the point and the color and puts out draw square point color. This is a good use of lambda. You know, a simple changing of the way the arguments are. Okay, so instead of regular old pix, put new pix. Now let's see if we can run this and get it. Yeah, I guess technically that's what I asked for, but that wasn't really what I was hoping to get. I was hoping to get alternating colors, black and white, horizontally, not vertically. So what could we do about this? Well, we could change the way we combine the colors, or we could change the order. I think we should just change the order. So about go through the Y's and then go through the X's. So that will make the horizontal go red, black. And then it should start with red on the next row. If you wanted to be more different about this, you could work with X and Y being integer and add the even or odd color. But fortunately with my setup, I've managed to get odd number across the horizontally. So when I fill in, first pick Y and then go through all the X's, I get my nice pattern this way. Okay. All right. So this is in general, this pattern of figuring out a bunch of points and then separately doing the colors and matching them is quite effective. So I would suggest you could learn that. It's almost the end, but I want to point out that this process of taking an ordered pair and turning it into a non-ordered pair function happens a lot. It actually has a name. So this process is called currying or uncurrying. There's actually a function that that does it for you. So if you have the draw square function which is a function of 2 inputs, and you want to turn it into a function of 1 input, vice versa, uncurry. So the uncurry function takes in, it's the difference between an ordered pair input and a 2 input. So uncurry is taking in a function that takes in an x and a y, and putting out a function that takes in ordered pair x, and currying then does the opposite, takes in a function ordered pair x, y, puts out a function that separate input. I'm going to run this. Oops, I didn't even show it, but draw new pix and new pix 2 will have the same result. If this is one of those places where if it compiles, it works. But I guess I'll have to run it again to convince you. New pix 2 is exactly this, as you'll see. Okay, fabulous. So now you've seen it all, and you even got the surprise introduction to currying and uncurrying. So I hope you enjoyed it.